experiment. Today's experiment I'll be handling with 3A and 3B. So the experiment is on first is all one is about your exceptions. Hope my screen is shared. Um, I hope you guys can see the question. Today I'm dealing with the third experiment, A and B. In that again we have two parts. The first part is about computing the quotient of a particular numerator and denominator. If there is any divide by zero, you should raise an exception. In our normal, say, cases like in C programming, if anything you get the number with divided by zero, then definitely it is like an infinite loop. But in object-oriented, Java takes care of the exception. So such type of all things are treated as exceptions. So Java will take care of the exception. That is the first part of your experiment. The other part of experiment is to implement a multi-threaded application. So mean you will try to create three threads. The first thread generates the random integer for every second. Second thread computes the square of that number. And the third thread prints the number, the value of the cube of the given number. Now, try to understand threads are actually a very lightweight process. Or if you have one particular huge program, the program is divided with number of threads. So individual instructions of the code are executed by threads. So only they say is a lightweight process. Now what we try to do in this program is explicitly we try to create threads and assign the task of the what is given like the first generating the random number, and the second after generating the random number the next will square that number, and the third one will automatically queue that number. So it's like multiple processes running at one point of time. So we'll try to work on these two experiments today. Okay, so anybody have any questions before I could go ahead? So these two experiments I'm working on today. So if you still need in detail of the explanation of multi-threaded applications or how to define multi-threads and how to work with multi-threads, we'll have in detail about multi-threaded concepts or multi-threaded programming in Java, maybe in the end of the third module or fourth module, learn about multi-threaded. So coming back to your experiments, if you just observe this, there are totally 60, totally enrolled is 91 out of 137. The only 91 have been enrolled. I don't know where the rest 40 plus students. Reminding you again, you guys should register here and submit all the experiments. The experiments are given till this Saturday. So by the end of this Saturday, you must have completed the experiment. That means you should have been submitted here for the experiment. Only then you will be evaluated further. Okay, so I'm putting that straightforward that if you have not submitted the experiment, you are the held responsible. So again, everything is given by me itself. We just take the things, dump it, and execute it and submit. That's the only thing you need to do that. So for your understandings, I have given two experiments as of now. Um, as we proceed, we'll continue with the additional experiment. Now let me move on to experiment number 3. That is, first part is the division of two numbers. If there is any divide by zero, you should get an exception. So mainly we are not interested in dividing the number, but we are more interested in how exactly an Java takes care of the. So there are two particular concepts to write the program. Two methods or two steps. One is try and the other one is catch. Um, we will try to do something like two things: try and catch. So in try, we will try to write the expression. If try throws any error, that will be since we are reading A and B, seeking that the first number is any problem. Am I connected? Can you give me a confirmation? Yes, no?
Yes, sir.
Am I audible?
Yes, sir.
I thought I was disconnected. Please, can you give me a confirmation? Am I connected?
Yes, sir. Yes, sir.
Fine. I thought I'm disconnected. No problem. Thank you. The first number is treated as the numerator. And thanks. First number is treated as the numerator. So I will take the input from standard input device. Similarly, I will consider the second number as denominator, and then I will try to write two blocks: try block and catch block. So we will try to understand in detail what is this try block and what is this catch block. Maybe after one or two. So please remember in Java we say this is like a block. The start the this is the opening parenthesis and this is the closing parenthesis. So this is called the try blocker. So inside whatever I write, this belongs to try block and the catch block is this. Okay, so the catch definition lies till here, till where you write the current phrases. Now, normally what we do is we try to write what actually we want to do. That we will write in try block. And if something goes wrong, or who has to take care about the exception, that will be thrown to catch block. That's how we try to execute the thing. So in try block, we try to write the to find the quotient. Quotient is equal to straight away a by b and printed quotient. Suppose if there is any error thrown by try block, that will throw to the catch block. Or the catch block will try to identify that particular say error or exception and try to resolve that using some type. So in catch block, you have different, you need to specify what are the different types of exception. Now, please remember what do you mean by exception firstly. So exception is something like a software error, or it is not an actual error. It is something which is I mean, not actually the proper logic. So when I'm telling to find out the quotient, there are chances that I need to pass on the specific values or integer values or zero, not the zero values. But if the programmer who was trying to give the input has done a trick to give the zero numbers, then certainly we may go to exception case. So it is like a trap. Exceptions are normally called as a trap, a software trap, where you are being dumped to a particular domain where it's very difficult for us to come out of it. So it is a trap. Exception is normally or is also called as a trap. So you try to dump or put that data or put that program into a particular dump or you trap where you cannot come out of it. But in object oriented, your systems are so smart that even if you try to give some certain kind of errors, they will take care of all such exceptions. So that is how exception handling will be taken care in object oriented programming. All right. So uh, likewise, divide by zero or array bound checking. There are some examples to quote. Memory assignments, operators, freeing the memory. They are all certain concepts where object oriented and Java takes care of all performing a clean sweep applications after the termination of the program. All right, so that's all about that. Please try to understand what is an exception. Exception is like a software trap where you come to a situation where it's very difficult to come out of it. But Java takes care of all that in a very clean manner. So you need to define the catch block with the help of I am trying to write an arithmetic exception here. If arithmetic throws any exception, what I need to do, I need to just print that what is the problem. So one thing, please try to understand how things are being written in your system. If you could just load, so I will try to write and show you. Um, see, if you have any idea about how errors are being taken care? Anybody have any idea about that? Yes, no? Please remember the arrangement of the system taking care of errors. Um, Normally, what happens? You have n number of errors, n type of errors. Okay. So all errors are defined in one header file called as uh, S, err.h. Error error number.h. Okay, so this will be hash include. Okay, so please try to remember that. So error number.h. So this error number is associated with the numbers of all the errors. Okay, so on in any programming language you try to consider, there are n number of type of errors, and each type of error is associated with a message. Okay, so you have error numbers. So if there is any error number one, error number one will have one message. Error number two will have a message. On. Okay, so all these are placed in error number.h. So um, when any uh, program throws an error, it will throw the error number. Okay, so it will try to identify what type of the number it is. For example, if I say semicolon is missing. So if I say semicolon is missing, your system will tell, okay, it will find out what is the error number here. Imagine semicolon missing is error number 4. So error number 4 is like statement missing will be the message. So here it is like statement missing. Okay, so the moment if anybody misses semicolon in the program, your compilation at the compilation time, your system verifies or identifies or try to look into the semicolon. Since it could not find, it will raise an error, and error will be found out which particular error number it is. So error number 4 is passed, and this 4 will have a message, a statement missing as the message. So pertaining to this particular number, this message here from the error number is extracted and displayed in DOS to see what type of error. So all the error messages are written in header standard header file error number.h. Um, and you have one more specific called as std error. Okay, std error standard error.h. So in this file, we'll try to link the errors with respect to your compilation. So error number will have the particular message. So that will dump to the standard error, and from standard error, it will try to identify what is the message for that particular error number, and that number will display the particular message out. Can you guys give me a response that you guys are listening? Hope you guys are understanding how things are being planned. You take any programming language, this is how they will plan. Every type of error will be identified and be listed in one particular error, one file. From that file, you try to link you try to identify what is the type of the error, and type of error will have a message associating with that number. So standard error when compilation takes place, number is thrown. That number is identified in standard error number.h, and extracting the message from there, it will display into the DOS to give an indication that this is the type of the error being occurred while compiling it. I hope I have covered what has to be told for the exceptions and other things. Any questions before I go ahead? Anybody have any questions, any doubts? No, yes?
No, sir.
Any, no doubts? Great. So let me run this program. So in your output, you please include both the outputs. Both the output means one for example, if I take 6 as the number, and next if I take 76, the quotient is 0.00 something else. My intention of telling both the means one is both the numbers, and the other one you try to do with respect to giving um, 0 as your number. So the moment you give 0 as the denominator, you will see like this: Java dot language dot arithmetic exception C followed by divide by 0. This is the message associated where from the arithmetic exception file. In this file, you mean in order to display this message, you need someone who will bring this message from the error.h file. And this error.h file is being placed like this: java.lang.arithmetic exception. In arithmetic exception, you have list of all the type of errors. In that, there will be one specific number called as divide by 0. So this divide by 0 will be holding one particular number. Okay, so in order to bring this message, I need someone who will bring that message for me. So who will bring for me? This particular object is created in order to bring me that particular value from the memory or from the files where I do have that particular value for it. So only I create one object here. So arithmetic exception, I'll create one object here, AE. This AE is responsible to bring me what actually the message is holding for this particular type of value. Okay, again, the program is very simple. I'm not taking much time to deliver all the things. Okay, so if anybody have any doubts or any questions, I'm waiting for a few more seconds. If anybody has questions, they can interrupt me, else I will go with the next part. No questions? All right, so let me go to the next part. If anybody have any questions, you're free to ask. Now, please come to the program. The program is to go with the multi-threaded programming. So when you're doing multi-threaded programming, you need to import the features of thread. Okay, so uh, to tell you more in detail, you need to have the copy of thread structure, how the threads will work, how the thread features have to be working at the backend. In order to carry all that features of thread, I need to inherit the properties of thread. So in order to uh, inherit the properties of thread, I am using inheritance concept here using extends thread. Now thread is already a class with the style of how to take care of the executions. So I'm extending that in my program. So this is the class program. I'm doing square here and I'm doing cube here. So normally I need to have three threads, right? So in my program, I have three threads. So one for square, one for cube, the other one to take care of the creating the random thread. So three tasks have been assigned. The first one is to randomly create one number, and that number should be thrown to identify its square, and the same number will be thrown again to for the cube to find the cube. All right, so three threads we are creating. Now whenever I'm trying to create threads, I need to import the features of thread by saying extends thread. So class name followed by this particular class will import the features of thread here. That thread will not run unless and until I write void run. So run is the particular method or to invoke the function of a thread through random thread, or in any program you or any multi-threading program you try to understand, I need to explicitly say run. Only then it will work. And certainly I'm again trying to do some other tasks like I need to make uh, the the parent thread to wait. We'll tell you just later. Now, please try to understand the tasks in this program. The task in this program is to what? Is to create three multiple threads, multi-threading, or simultaneously three things should execute. So one will create a random number. One thread will create a random number. The second thread will find its square, and the third thread will automatically create the cube of the particular given number. Now, any thread which you are been trying to invoking, that will invoke only when you write run. So now you have imported here the thread and the features. It will not run unless and until you write this run. Okay, so please try to remember that. And then okay, now what I'm trying to do is I'm trying to tell you two simple things. First is about your parent and child processes. I think I have covered that, but still I will brush up so that if you have not understood, I will reframe it again. Uh, See, there are only two types of processes: parent process, child process. Let me clear this for a moment. So I have parent process, I have child process. Now, when parent creates child, now both parent and child can simultaneously execute, maybe for same task or maybe for different tasks. It's immediate. Now, parent have to explicitly wait till child terminates. Once the child terminates, parent should note down the termination status of the child. Now, if the parent terminates and the child is still continuously executing, then who will note down the termination status of the child? Okay, so it's very difficult. So, in order to resolve this problem, what we do, we make the parent to wait. Okay, so when you look into the attributes of any file, or when you look to the attributes, or generally file attributes, in file attributes you will see what is the process id, parent id, group id, session id, a file inode number, file modification time, file size, last access time, last change time. These are like the file attributes what we try to observe. So in those things, you always have a parent ID. This is called as PPID, parent process ID. Okay, so please remember every process will have um, a different ID. Every process will have a different ID. Now imagine one parent process can create n number of child processes. Now remember, if, or just for a simple example, one parent has created three child processes. So all these three processes IDs will be different, but for all the three processes, their parent ID will be same. Okay, so all the parent ID for all the child processes remain same. Now, when I'm trying to import the features of thread, when I'm trying to import in random number, and one is the square, and the other one is cube. When I'm doing so, my thread will be the first parent process for these processes. So these will be like my child processes. Okay, so these are my child processes, and this is my parent process. Now, the normal procedure is parent have to wait till the child terminates. Okay, we cannot predict that which child will terminate first, or the maybe the parent may also terminate. So what we try to do is we try to make the parent to wait for long time till all the child process completes. Okay, this is like a hierarchy. This child may create another child may create another child, and so on. Maybe like a chain process. Okay, see, when this is the child process, this cannot terminate till this terminates. When this terminates, this can terminate. Till this terminates, this cannot terminate. Okay. Hope you guys are understanding. Any doubts? I hope you guys are understanding. See, please remember, a kernel cannot handle or manage all these things, and we need to have, a relationship in the processes. Okay, if I have a huge bigger task, what I will try to do is I will try to create n number of child processes and try to reduce the headache on the parent, and there will be multiple processes which simultaneously execute and make the system to run pretty faster. That's the advantage. But the only thing is parent have to wait till all the child terminates. Now in the same program, you try to observe One specific line is this: thread dot sleep of 1000. So let me tell you, I have wait, wait ID, wait ID, wait PID. These are the inbuilt functions which will take care of the particular process to wait. When I say wait, I need to pass on okay, which for which particular. When I say wait, all process will be waiting, uh, followed by number of seconds. Wait ID in the sense a particular a group of processes waiting for so many seconds. Wait PID means it will wait of a particular process followed by number of seconds given. Sleep in the sense sleep will be followed a particular time which will be assigned to a particular process. Are you understanding? Anybody have any doubts? Any clarifications, guys? Are you understanding? Yes, no? Give me confirmation. Are you listening? Can you give me a
Yes,
confirmation,
sir.
guys? So, hope you guys are understanding. So, what I will try to do, I will try to make the parent to wait. Why the parent have to wait? The parent have to note down the termination status. Okay. Mean now here in this program, now thread is my parent process, random number, rand thread, cube and square are the child process. So I need to make the thread process or the parent process to wait till the child process completes. Okay, understanding? Now try to observe each one particular class here. So there are so many classes. There are 4 different classes. In one class, I have main program, which takes care again reading one number to by importing one particular scanner, followed by how to read the standard input value. I use next int, and then first I will call one random number, and I will jump here to the random thread. So here I will try to create one random numbers. Okay, so random number between one particular range. And once I read this number, I will make the thread to wait, because when this initiates, this has to start. Okay, when this starts and after this square and cube can run simultaneously. Okay, so okay, here you see, once I prepare one random thread call, I will create the object for square, and I will the same thing I will object for, I'll create the object for cube. See, all the processes of which are running of maybe a thread process, I need to tell 2 things. One is start and run. Okay. If I don't tell start, it will not start. It will start, it will not run till I write run. Okay. So please, these 2 functions you please remember. I am creating the object, I am creating the a kind of environment here. I'm trying to create all the support here. Then I will tell start. So when I say start, thread initiates. Thread starts. So when it starts, what it has to do, it has to run. Okay, when it starts, it will take all the features of thread and come into this. So when it is coming into this, it will, what it has to do, it has to run. So when it has to run, it will go accordingly with this particular. So try to identify that number, random number, and sleep for a particular thing. If suppose if there is any exception or if there is any error, so print. If there, I mean, normally you don't get error for this particular thing, because you will have You will not have go out of the stack or something. Any questions? Any questions? Firstly, random number is called. Once the random number is called, and the same number is passed on to identify the square as well as cube. So let me run this and see how it looks or how it works. So it is asking me to enter one value. Let me say 7. And please see what has happened. So till the number of value 7, it starts. Random number is 14. First random number is 14. So cube of 1 is uh, say 1, and cube of 2 is 8. So till 7, it will I try to identify the cube root, and correspondingly it will identify to the square. Now please remember, in the cube it is till only 5. The loop is only counting till 5. I can even increase that, and every time it will go with the creating some random number. So my in the program it is I less than number, so it will go with the one number less than the what has been given. All right, so any more doubts? So this is the output. It will print all the values. Bigger the number, it will take more time to execute. If you have any doubts, you can still ask, or any questions. Hope everybody is watching. Any doubts so far? So let me rerun this. So let me give some other number. So let me give, this is like 4, and press enter, and see automatically things will happen here. Okay. So this is the execution of VB. So if you have any doubts, you can still ask. Anybody have any doubts? No? Any questions? Anybody have any questions? Okay, let me continue with one more program today. Experiment 4 also I will complete. This is quick sort. Have you heard about quick sort, guys? Quick sort. Have you heard?
Yes, sir.
Okay. The one is heard. What about others? Have you heard, guys? Yes, no?
Yes, sir.
Okay. Anybody have any questions? No? Please remember, all these sorting techniques, searching techniques should be always in your mind. That's how you should have a clear picture of the thing. So let me write something. So quick sort session 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 sort sort. Sort. Any other sorts? Selection sort. Any other sorting technique is missing, guys? Any sorting technique is missing? For yes,
Bubble sort, sir.
thank you so much. Very good. Is it Preksha Shetty who has answered? Yes. Preksha Shetty, you are the one who have responded.
No, sir, I'm BB Aisha, sir.
Thank you so much. Both of you guys, and thank you so much. Pranay is also answered. Okay, insertion sort is already written here. Some other things, radix sort, calculation sort. There are some sorting techniques which are out of our scope. So, calculation sort. So these are some of the sorting techniques which are out of our scope. So let us not worry about that. So this was the simplest technique which you have already known. All right. So please forget about the radix and calculations. So these are the major important sorting techniques. Uh, for your syllabus, you have quick sort and merge sort. So now I will teach you the quick sort, and then you can next week we'll go through merge sort and some other. So please try to understand the logic behind these sorting techniques. Okay, so if I tell you what is the technique for bubble sort is again very simple. Right, 7, 3, 2, 8, and 9. Okay, so can anybody just tell how bubble sort works? I'm talking to you guys. Around about 82 students. Please remember, bubble sort is one of the easiest technique. So you should know all the logics. Okay, so how each one particular logic selects, each works, which particular technique, how it works. You should have a clear picture of all these things. Yes, anybody just start talking. Please start with the initial technique called as bubble sort. All right. Can anybody say something about bubble sort? Yes. If you don't want to talk, then I cannot help it out.
Repeatedly swapping the adjacent elements if they are wrong.
Okay. Um, I was wondered, very first time when I heard this word called as bubble sort. What is this bubble sort doing with this? See, uh, you know, iteration. What is the meaning of iteration? Have you heard about the word iteration? Iteration. Some people say. You heard about that?
Yes, sir.
Okay. So when I start from left hand side, when I go to the right side, right hand, then I will say that one iteration is completed or one iteration is completed. They say. All right. So in bubble sort, what happens at the end of first iteration? Do you know? Very simple. The biggest element is sorted. Okay. So when I start left hand side, bubble sort is very simple. The first element is compared with the next adjacent element. 4 and 6 are compared. If 4 is bigger than 6, both are swapped. Else you just increment with the next element. Now 4 and 6 I compare. 4 is smaller, 6 is bigger. I leave 4 and come to 6 and I go and comparing with the next element. Now I compare 6 and 1. Now 6 is bigger than 1, so I swap 1 and 6. Now I go to the next way, next element is 6 and 5. So I again swap, 5 goes the other side, 6 comes here. 6 and 7 I compare. I see 7 is bigger, so I leave 6 and I catch hold of 7. Then I compare 7 and 3. 3 is swapped and 7 is replaced here. 7 and 2 I compare, again 2 comes here and 7 comes here. 8 and 7 are compared. I leave, there is no change, then I go back to 8 and 8 is compared with 9. Again, there is no change. So I complete my first iteration. So at the end of first iteration, I see that the last element or bigger element is sorted. Okay. Now next time, the next iteration, what I do, I start again from first element again. So here it is like 4, 1, 5, 6, 3, 2, 7, 8, 9, like that. Again, the story starts again by repeating the thing. Okay, so it takes time to complete all the iterations and you get the results one fine day. This is all about your bubble sort. Now, why the word bubble is, it will jump from here to next element. So the element will try to move or bubble from one location to the other location. If the first element is the highest element in the given list, then the first element will be bubbling to the end of its location. So that was the very simple problem for bubble sort. Now, when you come to other sorting techniques, quick sort is one of the technique where the elements are more sorted in a more faster manner. Now let me consider the same input and try to work on the quick sort. Now see, remember certain things in quick sort. Is it fine if I take it today or next week? I am not hearing any response from you people. Some people leaving the room. Anybody have any issues if I continue today? I find some 10 to 12 people have left the meeting. Anybody have any issues? Any
No, sir.
problems? No? Takes hardly a few minutes. I will run the quick sort and I will close. Hardly 10 to 15 minutes. See, I will take two elements, two iteration things, I and j. So I will be pointing to the first element. They will be pointing to the last element. So I will fix the positions of I and j. And one more I will have as my a pivot element. Okay, a pivot element is something like an element after first iteration, left hand side of the mean at the end of first iteration, pivot element will be sorted. Okay, that's how you can just consider for a moment. Or for your understandings, if I say pivot element is like a reference, so somewhere from I need to start. Correct. So I will start from a particular pivot element. So I will consider one element as my pivot element. So from the array, I need to identify one particular element as pivot element from where I will start my sorting process. So I need to have a kind of reference from where I should start. I will start from my pivot element, something like that. Now, please remember three things I have. I have a pivot element, I have I and j. Now, uh, now imagine the pivot element is the first element. Maybe anything, but just try to consider my pivot element is something like the first element is 4. 4. Okay, I'll consider like that. My first element is maybe pivot element itself. Now I will try to uh, play now. I will try to start working on the quicksort technique. Now, initially, before the start, I have three things in my mind. One is I, pointing to the first element of the array, and second element is j, pointing to the last element of the array, and the third is a pivot element. Now I will begin the show. Now I will try to fix the positions of I and j. I and j have to be placed in certain locations. First is look fixing the positions of I and j, then finding out the positions of I and j, then correspondingly swapping. This is how we can um, go on with the things. Understanding? Understanding? Now, how I will start is I will start with the first element and I element. I will fix the I will increment I, and I will decrement j. Okay. I will increment I will decrement j. Because I cannot decrement I cannot increment j, because I is pointing to first element, j is pointing to last element. Now I will start incrementing I. Similarly, I will start decrementing j. Now how to do that? Please try to understand. Once I know the positions of I and j, I will try to find out three conditions. Where is I? Where is j? Where is the pivot element? Correspondingly, I try to do this swapping. Okay, now try to understand. Now first, how I need to pass on I will increment I till I get an element which is bigger than the pivot element. Okay, so I will fix the position of I where till I find an element which is greater than the pivot element. The pivot element is 4. I will start finding an element which is bigger than the pivot element. Wherever may be the element, I will try to move that. Okay. Now, what is happening? I will try to fix my I. Where I should fix? Wherever, first compare the first element with the pivot element. Whether any element which is bigger than the pivot element? Yes. 4 and 6 I compare. I see that 6 is greater than pivot element. So place I at the position of 6. Now similarly, go to J, decrement J till you find a smaller element than the pivot element. Okay. Now, when I come across, I see that um, I am decrementing j till I reach a position where I have 2. Okay, so I decrement j and I place my j where I place at the position 2. Okay, okay, try to understand. I increment I and decrement j. When I am doing so, I will fix the position of I and j. Once I have fixed the positions of I and j, I will try to find whether I and j have crossed or not crossed. I mean, once I fix the positions of I and j, three conditions arise. One is I has not crossed j has crossed I, and I and j are equal. Three conditions I arrive. Now, in this case, I and j have not crossed. See, corresponding to type of cross, I will identify the something else. So three conditions arrive. One is I has crossed j, mean I has crossed j like this, or j has crossed I, something like that. Now, if I has not crossed a j, then what to do? Need to think. Okay, if I and j are equal, then what to do? Like that. Now, if I and j have crossed, any questions? Any questions? No? Anybody have any questions? No? Are you guys listening? Am I connected? Am I audible? Yes, no?
Yes, sir.
Yes, sir.
Yeah, I was not getting any response from you. You got it right? First, fix the positions of I and j. Okay, where how you'll fix? I you increment till you get the bigger element. Then you go to j wherever you get the smaller element than the pivot element. Now to do what? I need to check out the things whether I has crossed j or not crossed or equal to j. Sometimes I might have crossed, sometimes I might not. So fix the positions of the pivot. Now I and j have not crossed means swap I and j. Okay. If I has crossed j means swap j and pivot element. If both are equal, go with the j itself. Okay. Then continue the same process. So at the end of first iteration, what happens? You will get the pivot element sorted. So what happens here is, now in this case, 2 and 6 will swap. Again, things start. So 4 will come. Now I will be pointing to 5 and my j will be pointing to 3. Again, they both swap because still they have not crossed. Then again, I start comparing. My I will be pointing here and my j will be pointing here. Then replace. Okay, let me write down again just for my change. So what I did, what I said, I will try to replace 4. It was initially, I will try to replace 6 and 2. So 4, 2, 1, 5, 7, 3, 6, 6, 8, 9. This was the after the first swap. Now my I and j are where? I and j are pointing to 5th and 3rd. Okay, again they are not crossed. 5 is greater than 4 and also 3 is smaller than 4. So I and j position will be here. Now 3 and 7 will swap. So after 3 and 4 swapping, just see what happens. 4, 2, 1, 3, 7, 5, 6, 8, 9. Now fix the positions of I and j. Now j will be pointing where? J will be pointing to 3. I will be pointing to 7. Now what happens? They both have crossed. I and j have crossed. So pivot element and j element will be swapped. So when I swap that, so sorry, wait. Pivot element I and j have crossed. So I will be pointing here. Okay, I will be pointing here. Correct. Okay, now I is pointing here, j is pointing here. Since I and j have crossed, so swap j with pivot element. So when I swap that, what I will do? I will get here as, just a minute. When I swap these two, Okay, I has crossed J. So swap these two, then I should get in, yeah, here I should get 4. Okay, so 7, sorry, when I has crossed J, swap these two, then I will get 5 and 7. When I get 5 and 7, yeah, still it is not crossed, right? Yeah, still it's not crossed. So the positions are here. Now I will replace this 5 and 4 here. 5 has to come here. Okay, so 4 has to come between here. So end of first iteration, what happens is we will get 2, 1, 3, 4, sorry, 4, 5, 7, 6, 8, 9. End of first iteration, you will get like this. So if your pivot element was 4, left hand side of the pivot are one element, or one treated as one array, right hand side will be treated as another array. Now at the end of first iteration, your pivot element will be in its position. Now leaving the pivot element, this will be acting as one more array, and this will be acting as a one more array, and the same process will continue to redo the things again. Understanding? Any doubts, Baba? Yes. I'll do one thing. I'll reframe it, quick sort and merge sort again in the next class. Don't worry. I will just execute this. This is the program. Okay. See, in our program, we are doing something different. We are using the same logic, but I'm telling you something else. Okay. Okay. In I have, see, in this program, what we do is whether it is below 5,000, 5,000, greater than 5,000. Okay, quick sort I will do next week. If not, there's some error, I will check this. 63 pivot element plus high. Okay. Okay, now we'll stop. If not, I'll continue in the next week and show you quick sort and merger. I'll fix this. What is the problem? I'll just check it out, and I'll come back to this and let you know in the next week.